go. Okay, so we're going to put our count in here, right? Int count equals 0, count is less than size. We need to grab these two pieces, right? So I is not null. So we're going to think about where we have to deal with that. And theoretically, I could leave that in there. Okay, so I don't need to initialize, just so you guys understand this. I'm not going to make you do it right now. But theoretically, I could leave that in there. Yeah. So I could leave this I is not null in my conditions and increment both these things. Okay, but we're not going to do that because we're trying to keep it back to where we had. All right, so now what do I have to do with that I is not null? Yeah, I could do, I guess I could do a while loop in here, or I could do, what else could I do? While, yeah, while.
Just use an if statement to check if it's not, if that condition is true.
Yeah, if I is not null, we're going to do that. That's going to be easier than a while loop because it saves us time. And then I have to do I equals I dot next, so we just grab that piece. And where am I going to increment I? That's the only trick. Inside the for loop, right? Out down here, I equals I dot next. And then we'll just throw in the print. I don't know why I have the print statement at the bottom. Let's just go ahead and run this again and see if it still gives me the same thing. Still should give, whoops, what did I do? Oh, forgot to throw in a semicolon there. And we'll run that one more time. There we go, 2, 3, 10. So that should look something more familiar, right? We initialize our node, right? We have a count that's counts less than size. If I is not null, then we print out the item, and then I just increment through I. Does that make sense? This should look, does this look, could we theoretically, more or less, go grab our code from get? Right? If I grabbed this code from get and just threw in a print statement, would it work?
Yeah, but the time complexity gets worse.
Not if I print, no, not if I, not using get, but just grabbing this code and putting it down here.
Oh.
And then throwing a print statement. Right? It is essentially the exact same. If we think about it, node I, node pointer equals sentinel.next. I, if I said I was, using count instead of I. Here I is less than x, but now I just need to go through everything because it's size. And then pointer equals pointer.next. And instead of returning it, I'm just printing it. And I'm making sure that I is not null. Why do I know, why do I have to have this if I does not equal null when I don't up here? Should I theoretically have something in here that has that conditional in there?
Yeah, because if x is greater than size.
If x is greater than size, so I'd probably put in a condition like that at the start of it, right? If x is greater than size, throw some sort of error. If it's less than size, I know that all of those next statements are in there, so I know I'll never hit a null. Okay? And actually, theoretically, if I'm only going up to size, I don't think I should. I don't think I need to do that. Right?
Oh, right.
I don't need that statement. Because in a SList, if it's how do I know that everything is there's nothing null up to size? Because I can only add. I'm only attaching things on the end, right? And every time I add something or subtract something, I'm dealing with size, so I know there can't be anything null in there. That's not true. Theoretically, if I called print on an empty list, we'd be out of luck. Right? So if I go here and I call L1.print, we're going to have an error. Yeah. Oops.
Oh, we're good.
No, we are good. Why are we good? Because sentinel.next, I is null. We're not iterating. Right.
Yeah, there's no size.
there's no size. Okay, cool, never mind. Had to think that one through. It's been a long day. Okay. I was hoping to get to more than that. Actually, we're going to get to more than that. Ready? We're going to create a rotating SList. So everyone create a new class in here. Rotating SList. We got a whopping 6 minutes to do our rotating SList. Okay, so our rotating SList is going to do everything that an SList does. However, it has one more thing that it does. It rotates. What do I mean by rotate? It does this. Am I in the right place? I am in the right place. So our rotating SList. Default methods. We did default methods. Overriding default methods. Actually, I'm curious what he did. P equals, oh, he did it a little bit differently. P does not equal null. P equals P dot next. P dot item. Why did I use count? We could have just done this.
Oh, that's right.
Yeah.
You don't have to use size.
We don't have to use size, and we don't have to use, because of the way it's linked. That was silly. Okay, whatever. That's the simpler way to write that code. Okay. Yeah, we're going to get into static and dynamic types. No. Where did my rotating SList go? Oh, rotating SList. Here we go. So what a rotating SList does is this. If we have 5, 9, 15, 22, it takes the last item and puts it in front. Okay? So what do we want to do? It does everything an SList does, but it has this one extra method. It has a rotate method.
We want to move the set method. Or no, we want to
no. But what are my options in terms of creating the whole class? Right? My rotating SList, I could do what? What's the naive approach? If you didn't know computer science, what would you do? You'd copy everything and just drop it into a new thing. Is that pretty easy? What's that? I mean, if we copied everything in SList and dropped it into our rotating SList, right? We could do that, but what should we do? What is this? Oh. We should what? Extra pointer? What? We should make it a subclass. How do we make it a subclass? Extends. So our rotating SList is going to extend SList. Sorry, Logan, what were you saying? Yeah. And so you just extend it. Again, make sure that you include the generic type here, because it's really, I find it easy to forget this piece, like, oh, I'm extending SList. And it'll get really funky because it'll be like, hey, raw use of parameterized type class SList, because that's a really odd, like that's not a particularly useful error message. Okay? What does that even mean? Raw use of parameterized class? Well, what it means is that you forgot to include your generics. And then that error message goes away. So try to write your rotate right method. What did I do with this? If you think about this, I want you, so Gordon, go ahead and say what you were going to say, and then I'm going to give you a little bit of a thing.
You probably have to change the pointer that is attached to Sentinel.
Okay, so we're going to change the pointer that's attached to Sentinel. Then what?
Then we have to put the original pointer that's attached to Sentinel to the back.
Okay. So we're going to do something like, we're going to grab, because this, if sentinel.next would be 5. So we'd make sentinel.next 22. What just happened to 5 if we did that? We lost the pointer. So you make another pointer to sentinel.next, yep.
Yeah, and then when you have to, I'm pretty sure you iterate through the end of it and then make the end of that dot next equal to first node of whatever that is, and then just make the next thing.
Yeah. So so we'd go through, we'd find out, we'd go till dot next is null, then we make that dot next equal to that thing. But stop for a second. hopefully, and I may have again screwed this one up. What are we doing?
Swapping.
Well, we are swapping. What with what?
The first and the last.
Are we swapping first and last?
Oh no.
No.
You're
We're grabbing last and
putting it in front.
adding it to the front. Oh, wait. Think. Add first. Oh, and remove last. Oh, let's go look at our SList for a second. We should have a remove last. And this is where I might be screwing this up. I definitely should have an add first. We do? And we have a remove last. Ready? Guess what? What do we have to do? We're going to say T thing equals remove last. Add first. Oh wait. Equals. Oh, we got to think about what's going on there.
I don't think
Do we not have remove last?
Yeah, I don't think so.
We should have remove last. You have remove last? I know why you have remove last, but that's okay. Do I not have a remove last in here either? No. I don't. I've got add last. Do we have add first?
Yeah.
Yeah, we have add first. So we could at least use add first, right? So what we can do is we can go find the thing that's at the last, and then we could simply take that thing, right? T thing equals, we'll start with T thing equals null, right? Then we're going to have to iterate through, and then at the very end we'll do add first thing, right?
The thing is the thing we're trying to store at the end that we're trying to put in the front.
Yeah, so obviously calling it a thing is a bad idea. So like item to move. How about that?
Yeah.
We'll call it item to move. Okay?
Do we have to make it not static? It's giving me like problems.
Yeah.
Public static.
I mean,
But we want it to apply to.
Yeah, we want this one to be static, right? So we'll look at what the error message is because we got to go. But we'll tackle that next time. But that's the idea that we're going to try and implement there. Okay? And maybe what I'll have you do is try to actually implement rotate right. Now that we have add first, see if you can implement this.
Yeah.
For homework. Oh, didn't mean to do that. What I meant to do is that. Have an awesome rest of the day. Assignments. Oh yeah, you don't have to go anywhere. Lucky you.
No, I put it there.
PW15. What's PW15 right now? All right, I will see you later. All right. Have a great rest of the day. Have a good day.
Other trophies, the CCS trophies too.
And what is our rotating? What's our class called?
rotating SLList.
Rotating
Thank
SList.
you, Mr. McConnell.
Yep. Have a great rest of the day.
What was the vengeful SLList?
We're gonna do vengeful SList next.
Vengeful?
Vengeful SList. Yes. What are we? October Friday. Of course. Class hasn't even started yet. You don't even have to ask. Stroff showed up, didn't he? What's that? For using the bathroom? Yeah, no, it's. I'm of the opinion that if someone thinks they need to go to the bathroom, then they should probably go to the bathroom.
Wholeheartedly
So
agree.
true.
you all, especially as juniors and seniors in high school, should be able to figure that piece out.
I agree.
When you get to college.
When you get to college,
Although, when you get to college, walking out of a lecture hall it can be really awkward, yeah.
They don't take, there's no attendance or anything, right?
I mean, in a lecture hall, not usually. So, no, it's just